Okay, good morning. This is April 29th, 2019. This is your grade 9 3-question warm-up. The first two questions in your warm-up are from section 10.1 in your textbook on inscribed and central angles. And the second or the third question is from 10.2 on perpendicular bisectors to chords and the properties that are associated with it. So we're going to look at these three questions, see how well you did. So the first question gives you a circle with a whole lot of different things going on and says how many degrees is x right here? How many degrees is this? So the first thing we notice, I forget what letters did I give this and this? E and F? E and F? B, what? D and E, and this one here is F. Okay, so D, I'll erase this one here. So this is D. So D and E are 2 points on the circle that are connected to the middle. So we know that this is what we call a central angle. Okay, we know that that's a central angle. However, it is a central angle that has no inscribed angles to it. There are no other points that D and E are connected to. So therefore, it's a central angle without a relationship. There is nothing connected to D and E aside from the central point. So it is a central angle that is superfluous. It doesn't matter to the answer for x. So what we have here is we do have A and B that are not connected to the point in the middle, but if they were, we would be able to figure out how many degrees it was because A and B are also connected to point C, forming an inscribed angle. I'll erase this here. It's an inscribed angle to a central angle that doesn't exist. There is no central angle, but we don't need it. We know that A and B are connected to C, making 12 degrees. So any point that A and B are going to be connected to, including the red ones, are going to make an inscribed angle to AB that's the same measure as the first one. So therefore, x would also be 12 degrees. Now if I go back in time to that whole conversation about a central angle that doesn't exist, and I took my green marker, I'll make it a little bit bigger so we can see it. I took my green marker and connected A and B to the middle, okay, and asked you how many degrees, what is angle AGB? Well, now I know that AB is formed two inscribed angles, one to C and one to F, making them 12 degrees, which would tell me that the central angle would be double that, which would be 24 degrees. But the question doesn't exist. It's not there. So we don't need to worry about it. But what we do need to know is that this central angle is a central angle, but because points D and E were not connected to any other point, they don't make inscribed angles, and it's not necessary for the information we're looking for. Okay? In your second question, you're given a circle, and it asks you, I don't even know if it asks you anything. Did it ask you something? How long was what? Oh yeah, so right here is X, okay. Oh no, sorry, not the AC, sorry. Oh, heavens to Betsy. So AC says how long is X, okay? So with AB, we know that that's going through the middle, and what we recognize is that being a diameter. It doesn't say that it's a diameter, but we assume that it's a diameter because it's a straight line. I should have actually wrote that down, but I didn't. And because it is a diameter, we know that it's also 180 degrees. A straight line makes 180 degrees. And the other thing it also does is because 2 points are connected to the middle, that 180 degrees is also a central angle. Okay, with an E. Now when those A and B points are connected to any other point outside of the middle, like point C, this will be an inscribed angle. And since it's inscribed to the central angle of 180, it is also 90 degrees. So then what we see, if I grab my blue pen here and I trace this out, I now have a blue, if I can take, ooh, look at that, perfect. I can rotate it. I can bring her down here, shrink it up a bit maybe. Bring it, come on now, be good. Bring it over here, and I have a right triangle that doesn't look like a right triangle, but it is, because I've already defined it as being right. This bottom one would be X. This distance here is really the hypotenuse of my right triangle, which makes it 12 centimeters. And the BC is this short leg, which is 5. So what I end up with is a Pythagoras question that has an X as my AC line, and that's what I'm solving for. So Two ways to do it. The one we usually use is the squares on here. 144 over here and 25, which would make this one 119. And it would make x the square root of 119, which if I grab my calculator and go square root of 119, should be roughly 10.9 or 8. 10.9. And therefore, this distance is approximately 10.9 centimeters long. Okay? Again, alternatively, you could have used a squared plus b squared equals c squared. Substituted your a and your b and your c. So 5 squared plus x squared equals 12 squared. And when you simplified it, you still would have got the answer of 10.9. So if you got 13 as your answer, what you did is you assumed that Pythagoras said the area of the two squares that I do know will always add up to the area of the square I don't know. And that's the common flaw in Pythagoras. He did not say two squares you know will add up to the one you don't. He said the area of the two squares attached to the legs will add up to this. So it's not 44 plus 25 equals 169. One thing I forgot to mention is over here, we have two pieces of superfluous information again, not necessary to solve the question is how long is x, but they are there to kind of throw you off. Maybe those are important numbers. So it's important that you know what numbers are important and which numbers aren't. In your third question from 10.2, we have two pieces of information. We know that FG, which is your diameter, is 18 centimeters long. And we know that AB, which is your chord, right here, this blue line, is 12 centimeters long. And we have this radius, CD, which unfortunately doesn't look like a straight line, but it is, that cuts chord AB perpendicularly at point E. So when that happens, the first thing you should do if you have this as a test question is do this. You know that when a radius cuts a chord perpendicularly, it cuts the chord into two equal halves. And since I know that AB was 12, then I know that AE is going to be half of that, which is 6 centimeters, because AE is half of the chord AB. Once I know that, the next part says what is AC, and since AC doesn't have a line, I'm going to have to connect those 2 points to make the line AC. I ask myself, how long is AC? Well, if the diameter is 18 centimeters, then that AC line is actually a radius, which means it's half of the diameter, which means we have a 9 centimeter line for AC. Okay. And what we probably also realize is that now that I've drawn that in, and the reason why I asked the question, oh, hang on, gotta grab, there we go, is now we have a right triangle. When I draw AC in, it actually completes a right triangle by making a hypotenuse. Okay? And if I plug that AC as being 9, and I plug that AE as being 6, then CE will be that remaining distance or that leg of the right triangle, and I can solve that using Pythagoras. So I'll do squares. 81 is here. 36 is here. Now it's not 117 for x, right? A common mistake would be to take the two squares you know and add them together. But 81 take away 36, for whatever reason my brain can't do that this morning. Take away 36 is 45, which means the area of that square is 45, which means the length of x, or the length of CE, will be the square root of 45. And it's an estimation because it's an irrational number, which means that x is roughly 6.7 centimeters long. So we're going to put 6.7 centimeters for the length of CE. And the last question says, how long is ED? Well, since this whole line right here is the same as this line and the same as this line because they're all radiuses, then we know that this whole CD is 9. And the 9 centimeter line, take away the 6.7 centimeter part, would be 2.3. Therefore, the remainder of that radius will be 2.3 centimeters long.